All right, guys. In this video, we're going to focus on the multiplication rules of probability. Questions 34, 35, and 36. Let's look at number 34. It says, a gumball machine contains 300 grape-flavored balls, 400 cherry-flavored balls, and 500 lemon-flavored balls. What is the probability of getting one grape ball, one cherry ball, and one lemon ball if each ball was removed and then replaced before choosing the next from the machine? All right. So we want to find the probability of a grape. So one grape, one cherry, and one lemon. So you're performing these events one after another after another. You choose a grape. Before you choose a second one, that ball is replaced. Then after that, you're choosing a cherry. Then after that, that ball is replaced. Then after that, you're choosing a lemon. And after that, it should be replaced. So there's an order to this, basically. That the first is grape, the second is cherry, and the third is lemon. We can use the multiplication rules of probability when you have two or more events happening in a sequence. Now look what it says here. And let me highlight it for you guys as well. If each ball was removed and then replaced before choosing the next from the machine, that indicates that the ball are replaced. There is replacement. When there's replacement and there's two or more events happening in a sequence, we can call these events as independent events. Let's rewrite that. Such that the probability of A and B, such that A comes first and B comes second, this equals to the probability of A times the probability of B. We're going to use the same theorem in this case. First, let's find how many balls are in total. 300 plus 400 is 700 plus 500 is 1200. So there are 1200 balls in total. Let's circle that and write that on top. The first one must be grape. What is the probability of selecting a grape? There are 300 grape flavored balls out of 1200. That's going to be 300 over 1200. Okay, you take a grape out, and as soon as you take it out, it's replaced. So that means for the second ball that you're choosing, there's still 1200 balls. And the second one is going to be cherry. And there are 400 cherries in this machine. So the probability of the second one being cherry is 400 out of 1200. You get a cherry. Before you go again, that is immediately replaced. So that means we still have 1200 to pick from for the for the third option. And the third option says there are 500 lemons. So the probability of the third one being lemon is 500. And because this is one event after another, we can multiply these probabilities together. Let's reduce these fractions first. The zeros at the end can simplify out. 3 divided by 12 is 1/4. Times Once again, the zeros at the end can simplify out. 4 divided by 12, that is 1/3. And then same thing for the last one. The zeros can divide each other out. 5 over 12, it can be reduced. Leave it as 5 over 12. And when we multiply everything, top, bottom, bottom, that's going to be 5 over 144. And let's divide that and take 4 numbers after the decimal. So let's go to our calculator. And that's going to be 0.0347. Take 4 numbers after the decimal. And that is the answer to this question. I'm sorry, guys, I took so long to get to the point in the beginning. I just want to make sure that you guys can be able to understand why we're doing what we're doing in this situation. All right. Number 35, the number 36. It says a bag contains 10 white, 12 blue, 13 red, 7 yellow, and 8 green wooded balls. Let's add it together first. 10 plus 12 is 22. 22 plus 13 is 35. Plus 7 is 42. Plus 8 is 50. So there are 50 balls in total. All right. It says a ball is selected from the bag and kept. When it says a ball is selected from the bag and it is kept, that means you are not replacing. Let's write this down. Not replacing. You then draw a second ball and it is kept as well. What is the probability of selecting 1 white and 1 blue ball? Round your answer to 4 decimal places. All right. So you want to find the probability of selecting a white first. So the first ball is white. And the second one is going to be blue. There is an order, one after another. However, in this case, you are not replacing. Because you are not replacing the ball, the events are dependent. And when you want to find the probability of 2 or more events, one after another, that are dependent, the probability of event A, which is the first event, and the probability of event B, which is the second event, is equal to the probability of the first event, A, times the probability of the second event, B, given that the first event has already occurred. All right. So, to find the probability that the first ball is white, there are 10 white balls in my bag out of a total of 50 balls. So the probability of selecting a white is going to be 10 out of 50. And it means to multiply. So let's put the multiplication symbol right there. Find the probability that the second ball is blue. But remember, the ball is kept. It is not being replaced. So if I take 1 white ball out of my bag, I no longer have 10 left. I now have 9. And if I remove 1 ball out of the bag in total, there's no longer 50 balls in the bag. There are now 49. Out of the 49 balls left in the bag, how many of those balls will be blue? And that is going to be 12. So 12 over 49. Reduce the fractions if you can. 10 over 50 reduces to 1/5. 12 over 49 cannot be reduced, so you leave it as 12 over 49. When you multiply this, you're going to get 12 on top. On the bottom, you're going to get 245. Divide that, and let's get 4 numbers after the decimal. So let's go to our calculator. 12 divided by 245. And that's going to be 0.049489. But this 7 will make this 89 round up to a 90. So our answer is going to be approximately 0.0490. And there you go. Just to recap. For the first one, you are replacing. That's why our denominators stay the same. But for the second one, you are keeping it. So your denominators must decrease by how many you're keeping every time you do this. Number 36. If you are dealt 2 cards successfully without replacement from a shuffled deck of 52 playing cards, find the probability that both cards are black. Express your answer as a simplified fraction. So you want to find the probability of 2 black cards. That equals to the probability of the first one being black and the second one being black. And it says, once again, without replacement. So that means when you select a card, you do not put it back into your deck. When it comes to our black cards, we know there are 26 black cards in our deck. Let's clear this. 52 cards in our deck in total. 26 of these cards are black cards. So we want to find the probability of 2 black cards. That means we must find the probability that the first card is black and then the second card is black. The probability that the first card will be black is going to be 26 out of 52. Now, you take 1 card out of your deck and you are not replacing it. So let's suppose we pick 1 black card. We're taking out the 5 of spades. That card is no longer left in our deck. If you remove that card from your deck, you now have 51 cards left to choose from. If you remove the 5 of spades out of your deck, you no longer have 26 black cards. You will now have 25 black cards. So the probability that the second card will be black will be 25 remaining black cards in our deck out of the 51 cards that remain in total. (26 out of 52 can be reduced to 1/2. So 1/2 times 25 over 51. 1 times 25 is 25. 2 times 51 is 102. And this is the answer as a reduced fraction. So once again, when you are not replacing, it will change your denominator. And if you're choosing 2 of the same, then it will also affect how many of that individual category you also have left. All right, guys, I'll catch you in the next one. Take care.